Alright, 8.5 today is proving triangles similar. And we are going to use many, ladies, let's go now. We're going to use many of the same lettering for our theorems today as we've used in the past. Okay, there's going to be a side, side, side. There's going to be a side, angle, side. Are they probably going to be exactly the same as the congruence ones, though? No. Okay, they will not be the same as the congruence terms that we learned last semester. Right now, how many ways do we have to prove triangles congruent, or similar? One. Angle, angle, right? Now, if they're similar, we know a handful of things, right? We know that all of the angles are congruent to the corresponding angles in the other triangle, right? And we also know that the sides are all what? Which they're the same ratio, which means they are, starts with a P, proportional. Not all the sides are parallel. Okay? They're proportional though. All your sides are proportional. The first thing we have is our first theorem, which is side, side, side similarity. And side, side, side similarity tells us something that we really already know. Okay? It tells us that if the sides if all of the sides of one triangle are proportional to all of the sides of another triangle, then the triangles are similar. If all of the sides of one triangle are proportional to all of the sides of another triangle, then the triangles are similar. Thanks, Braden. Okay. The diagram that you can put along with that, a lot of different diagrams you could draw, but the one I'll give you looks something like that. So I have triangle ABC and triangle DEF. What does segment AB go with? DE. So AB over DE must equal BC over EF, which must equal AC over DF. Didn't we already know that? Yeah, we've already talked about that. Okay, so we should already know that. That's actually just called your statement of proportionality, which we learned a few lessons ago. Okay, if that's true, if all of those ratios are equal to each other, then what do you know about those two triangles? The triangles are similar. Good. We have, we're doing an add-on assignment. It's on plan book. Okay, thanks, D'Angelo. Okay. questions on that one? Alright, that was side, side, side. The next one we have is side angle side similarity. Again, very close to our side angle side congruence, but it is a little bit different. I don't like how the book words this, so I'm going to change it up a little bit. I'm just going to write it in basically a different order. Okay, but it says that if two sides of one triangle are proportional to the corresponding two sides of another triangle, and their included angles are congruent, then the triangles are similar. If two sides of one triangle are proportional to the corresponding two sides of another triangle, and their included angles are congruent, then the triangles are similar. Okay, so when we're talking about similar triangles, do the corresponding sides have to be congruent to each other? No, they have to be proportional to each other, right? Okay. So you can draw a diagram for this one also if you'd like. Okay, so I have triangle ABC, DEF. So let's go ahead and use AB and BC. Okay, so I have AB over what? DE. And that's going to be equal to BC over EF. So I have that, and since I chose this side, and that one, what angles have to be congruent? B and E. So, and angle B is congruent to angle E. If this is the case, now that doesn't mean it has to be the case, right? If it is the case, what do you know about the two triangles? Then they're similar. Do you have to have that angle in the middle, in between them? Yes. That's very important for side angle side. Okay. Question on either of those theorems? Okay, the next thing I want to do is take a look at example 2. Everybody there? Example 2. Okay, it wants to know which of the following three triangles are similar. This is exactly what they're going to ask you on your first 3 questions of your homework. Okay, they're going to give you something exactly like this, and they're going to want to know which, if any, of the triangles are similar to each other. Okay, if they only give you side lengths like they do there, you're probably going to be looking for what theorem? Side, side, side. Because do you know anything about the angles? No. Okay, so we're looking for side, side, side here. Let's do the first and the second triangle. On the first and the second, okay, which side corresponds to 12? 8 does, right? So I have 12 over 8, which reduces to 3 over 2. Since that is the ratio of two sides, when I check the rest of the sides, what should their ratio be if they're similar? 3 over 2. If they're different, then they're just not similar, right? Okay. So what about the 6 on the first one? What's that? 4. 6 over 4 reduces to 3 over 2. And then 9 goes with 6 is 3 over 2. Notice some of you said, when I said the 6, you said 9. That would have been backwards, right? Because I was doing the first one to the second one. Okay, so everything's first to the second. Because if you flip one on accident, then you're going to think it's wrong, right? Make sure you go first to the second every time if that's how you start. So are those two triangles similar? Yes. So then on your homework, you would say that triangle blank is similar to triangle blank. And then you would tell me because of side, 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 right? Okay. Now, does that mean those are the only two that are similar? No. Okay, so let's check the last two. So I'm doing the middle one and the last one this time. So on the middle one, my 8 goes with what? Which reduces to 4 over 7. Okay. The red, the 4, goes with which reduces to? Do I need to go any further? No, I immediately now know those two triangles are not similar, right? Okay. From there, you have to decide, hey, is it possible for my first and my last one to be similar? No, if my first and my second one were similar, and my second and my third one were not, is it possible for my first and third to be? No. Okay, so I got to run through a few scenarios here with you. If your first and second are, and your last two, your middle and your second and your third are similar, what do you know about your first and your third? That they are similar. Why? Anybody remember that property? Jacob? It would be transitive. Yeah, that'd be your transitive property. If the first two are, and the second two are, then the first and the last must be also, right? That's transitive. Now, if the first two are not, and the last two are not, is it possible that the first and the last are? Yes. Okay, so in that case, you might have to check 3 times, right? Okay, so just be aware of that. There's different scenarios determining how much you have to check. Okay, I want you guys to go ahead and get this copied down for a proof. That's your next example.
Would you say what the second and third triangles are? Last scenario.
If the first and the second are not, and the second and the third are not, the first and the third might be.
Thank you.
Everybody see that okay? It'll be alright. We're getting close. Sorry, this should not be marked. My fault. Okay. Our directions tell us, this is example 3, it says use the given lengths to prove that triangle RST is similar to triangle PSQ. Okay, so we're proving, right? So we're doing a 2-column proof. Okay, so I'm setting up my statements and my reasons. And then 1 would be your givens. Hey, I'm not going to fill them in just for the sake of time here. Okay, but basically all they give you is your side lengths, right? Okay, they tell you SP is 4, PR is 12, SQ is 5, QT is 15. Okay. Missing a marker. There it is. Anybody have any thoughts for our first step? Royal? Angle S has to be congruent to angle S. Reason? Reflexive. Oops. Now, why does that do us any good? Right, and my 3 ways to possibly prove triangles similar: side, 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 angle, side, and angle, angle. Okay, so that helps us with 2. But just because I know an angle, does that mean I can eliminate side, side, side? No. But why can I eliminate side, 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 Taylor? I don't have all 3 sides. I have the 2 on the left, I have the one on the left, the one on the right, but I don't have either of the bases, do I? Okay, so side, side, side's out. Okay, because I would need something here, and I don't have it. And I can't find it because it's not a right triangle. Okay, so now I'm down to side, angle, and angle, angle. Everybody agree with that? Now before I call on anybody, I had somebody tell me last class that this angle SPQ is congruent to PRT because of corresponding angles. Seth is shaking his head no. Anybody tell me why? What, McKenna? The lines are not parallel. Now, might they be? Yeah, they might be. But they don't have to be, right? If they don't draw it and show you, okay, then don't just assume that they are. Okay, so we're going to assume that they're not. Okay, so with that, is there any way to get those 2 angles congruent? Or those 2? So is there any way I can get a second angle? No, so we just eliminated what? We just eliminated angle, angle. Okay, so now I know we're going after side, angle, side, right? Okay, so we're back over here. With that, what's my ratio I can set up, Taylor Hart? What ratios do you know? 4, very close. Now when you look at 4, that's the whole side length, right? There you go. So Taylor wants to do 4 over 16, which I agree with, which reduces to 1/4. Okay, so when I do the other side, it should reduce to what? 1/4. So I have 5 over 20. Is that 1/4? Yeah. Royal? Yeah. Because if you don't, then you can't say that they're proportional, because you didn't actually show me that they were. You have to show me everything you do. You can't skip around and just think things through in your head and not write it down. Okay? Now, this is where we struggled the last 2 classes. What am I going to say for a reason? Okay, because it's not side, angle, side, because side, angle, side would be proving my triangle similar already. What do you think, Jacob? What would you say? Okay, it could maybe be simplified. what we decided is that maybe we should say corresponding sides. Because why did I set up these ratios? Because my sides were corresponding, right? And I know that the ratio of my corresponding sides needs to be the same. Okay, so that's kind of what we decided would be the best scenario there, is just really explain why did we set those ratios up. And it's because they're corresponding sides. Okay, now I have two corresponding sides and one angle, or congruent, right? A pair of angles. Is it, you got to make sure, is it the included angle? Yes, it is. So can I say my triangles are similar now? Yes. So step 4 would be that triangle SPQ is similar to triangle SRT. Reason? Side angle side. Just be very aware, please. Is that the same side angle side we used last semester? No. It's really not even close. Okay, you're talking about proportional sides, not congruent sides. And please don't skip it just because it's a proof. Okay, that's never going to get you anywhere, skipping the challenging things in life. That won't get you anywhere. Okay, so do the hard things, give it a shot, and then ask questions if you have them. But try it. I don't want you to come back tomorrow with blank proofs. I want you to attempt them. Okay. Now the last thing I want to look at here is example 5. In example 5, this person is going to climb a rock wall. Obviously my rock wall is a much better diagram than theirs is. Okay. So what this person does, he first wants to know how tall or how much do I have to climb. Okay. So he starts at the base of the rock wall, backs up 85 feet, and lays something on the ground. What is it? A mirror. Okay, lays a mirror on the ground. And then he backs up until he can see the point of this rock wall right in the middle of the mirror. 6.5 feet is what it took. Okay. Now before he started this whole process, he went ahead and measured from his feet to his eyes, and he happened to know that from his feet to his eyes was 5 feet. Okay. And then his line of sight, where's he looking at? The mirror. He's looking down at the mirror. So his line of sight goes from here to here, and then the reflection goes up to that point. What did he create by doing this?
2 triangles.
Okay, 2 triangles that are what? They're similar to each other. Okay, those 2 triangles are similar to each other. So his whole goal here is to figure out how high it is, right? So he's trying to find out, what's that? Should he be able to set up a proportion to figure this out? Okay, Taylor Stokes, what would that proportion be? 6.5 over 85. 5 over x. Are there multiple ways to set that up? Yeah. Personally, I would have done 5 over x equals 6.5 over 85. People last class did 5 over 6.5 is x over 85. Does it matter? It doesn't matter as long as they have something in common. Okay, so I cross multiply. 85 times 5 is 425. X times 6.5 is 6.5x. Divide by 6.5. X equals 65.38 label feet. So the rock wall he has to climb is how tall? 65.38 feet tall. That's pretty tall. Anybody catch on why I did that example? That's what we're doing tomorrow, right? Okay, that's why you had to bring a mirror and tape measure. Okay, so that is what we are doing tomorrow in class. Tomorrow we, doing that exact same thing, are going to go down to the gym in the commons area. We will find the height, the height of the bleachers, the championship banners, the soundboards, the scoreboard, and then in the commons area, the clock, the TV, the ceiling, and then you'll come back in here and you'll find the height of this ceiling as well. Okay? So I'll group you up tomorrow and then we'll go down and we will do that for the class period. Okay? Questions on how we're going to do that or what the process would be? Okay, you get directly below whatever you're getting to, right? You measure from there and you go place the mirror on the ground. You know that distance. You back up until you see it in the middle of the mirror. You measure that distance. And then you measure from your heels to where? Your eyes. Don't measure to the top of your head, please. To your eyes, because your line of sight is not from up here, it's from your eyes, right? Would that extra 3 inches make a big difference? Yeah, make a big difference. Okay, so just be aware of that for tomorrow. That's what we will be doing class period tomorrow. Okay, now, let's go ahead and let's get started on our assignment here. We have page 492, 6 through 35, all. Omit 31 though.